G2P payments. This is an important piece of work that the community has undertaken. It's all about being able to make a payment to a MOSIP-based payment. So a G2P payment, very often a social payment, is all about the ability to make large volumes of payments to individuals, and very often sending it to the bank account or whatever is less efficient. It's much better to pay it to their identity and leave the routing of the association between an identity and the bank account to the individual. So the aim is to make social payment runs much more efficient and less error. This piece of work has been undertaken as a collaboration between different open source digital public goods projects. As you can see here, we have MOSIP, so this piece of work. A G2P beneficiary would have a MOSIP digital identity. MOSIP is an open source implementation of a nation scale digital identity system. Choosing MOSIP in this context was perhaps a brave decision because MOSIP is very strongly privacy preserving. So that made it more difficult to perpetuate an identity across the open source projects. If you're going to get this to work, then best to do it in the most difficult environment, and that's what we've done. In combination with MOSIP, we have obviously Modulo. We're providing the glue that sticks everything together. Roots between the organization that wants to make the social payments and the accounts where those payments are to be made into. And finally, we have MiFOS, which is an open source banking system. This is the banking system we've chosen to use for this particular demonstration. A G2P beneficiary, this context, and the context of this demo, has an account. What's missing in terms of the digital public good projects we could work with is the Open G2P project. And that's simply because that added an extra complexity just a little too far. So instead, we developed a concept of a port which could be integrated with G2P. You'll see that during the demo later. The partners in this effort, I think this is quite an important step for the innovation community. It's been led by Identities, in particular, Baker. He's done a huge amount of work on this. Very grateful to him for leading on this. And then we have worked again with systems, done a lot of work. And Elijah, who's done a great deal of integration work, particularly with MiFOS. I'm very proud to be able to say we've got this to work. It works end to end. I'm going to have done any of the work myself, but at least I provided the impetus. So with that, I'll hand over to Baker of Identities. Over to you, Paul.
Thank you, Paul. I've really enjoyed working on this project for a couple of reasons. The first one is I think this is a very valuable design for the G2P community, and I've loved working with the engineering teams proving out this design. The other reason is that it is a good match of the three digital public goods that we are tying together. I think it takes advantage what each of those are particularly good at. And lastly, it's been a community effort. And it's been an opportunity to get other people in the community directly involved in work stream delivery, which has been fantastic. So let me start by describing exactly what we built. Here on the slide, this purple circle represents our payment registration portal, which is really the key component that ties these three digital public goods together. What it provides is payment alias that is personalized. In other words, it has a personal profile or login or access, and we use MOSIP's identity registration function to perform that action. So let me give you a high-level view of it first, from the perspective of a person who requires a beneficiary payment. They go to the beneficiary organization. This might be a government or some NGO, and they register to try and get the benefit. And in the due diligence process, at some point, the beneficiary management system is going to want to work out how to pay that person. And that's where the payment registration board comes in. So we didn't build a beneficiary management system. We just mocked that up. We know that other people have done a really good job there, but we want to show how their system can use the payment token registration. How it does this is through a redirect. It's an OpenID Connect redirect, which is a fancy way of saying it's a remote login. So you just redirect to this remote login site, and then we leverage MOSIP to identify the person, and then we do some other checks, and then we create a payment token and return that token back to the beneficiary. What that means now is the beneficiary management system, whenever it needs to pay that individual, can use that token to make payment. It does this in the normal mechanisms through their bank that is connected to it. So why is this significant? It could just be a normal payment token. And the reason why it's significant is the benefactor can now go directly to the payment token registration and leverage the same login user identification method that we get from MOSIP, and then change their account information, and we'll perform the same set of checks that we did when we originally put that token together. The beneficiary can reset that token to a new account information. And then that payment token will continue to work, but now be redirected to the new payment token. Okay, I'm going to hand over to Eugene, who is going to take us through a more detailed walkthrough on exactly what happens during that payment token registration action.
Thanks, Paul, for such a detailed explanation. Before jumping to the demo, I'd like to provide you with UI screens to have a better understanding how all these components link together. As Paul mentioned, first of all, to get any payments, beneficiary should register payment token in a beneficiary management system. So here we can see the screen, and after clicking register token, the user will be redirected to MOSIP, which is representing national identity system. And using eSignet, it will be provided with a login screen where the user could provide the personal information, and the return Signet will return back to the payment token registration portal the token. After that, registration portal will ask user to provide a type of payments and identifier to which this payment token will be linked. And when the user provides all needed details, the token registration portal will do a discovery call to Magalu to check if this account exists and get some personal information. As a minimum, it could include person's name, but optionally, it could include full name, date of birth, and any number of KYC information. So having these two pieces of information about the user, portal will do KYC checks, and in case validation is passed, I mean, in our presentation, we will check full username. Portal will create a payment token and then register it in payment token adapter on pair DFSP, and also in a module. After that, the token will be returned to the beneficiary management system and can be used in the further payments. Let's try to see how it works in real demo. And first of all, we navigate to beneficiary management system. For now, it's just mock system, but to get an understanding of how it works, I think it's fine. So first of all, we need to obtain payment token, and we click register token button. As I said, at this moment, we were redirected to MOSIP, and in terms, MOSIP, which is a national identity system, uses a signet to provide the user with a login screen where we can choose a couple of options to identify ourselves. As you can see, now we have begin by one-time password and biometrics. Let's use for this demo one-time password. And after that, we have to provide our VID, which we received from MOSIP during the initial registration on this system. I will use mine. So eSignet checks if the user exists on the platform, and after that, it sends me to register an email, one-time password, which I can use. This one to log in to the MOSIP. After that, MOSIP validate my credentials and turns token back to the portal. Currently, the user is asked to provide details where the payment should be redirected to, and in our demo, let's use the IBAN identity type. And I have prepared the test account. And after the clicking the button, as I said, the call to module to get party information will be made, so-called discovery call. And after that, details of the user in Mythos and MOSIP platforms will be checked. And if everything passed successfully, as we can see, the payment token is created. And we can use this token further for the payments. Right now, after redirect to the beneficiary management system, this portal stores this token and will use it, as I said, for the further payments. And I'd like to turn over to Elijah to show you how the payments can be made.
Okay, thank you so much, Eugene, for the demonstration. So what I'm going to demonstrate is the operator of the beneficiary management system making a payment to a beneficiary alias was registered. So in this scenario, the government is going to make a beneficiary token was registered. We can see in bottom right corner, there's a screenshot that has just appeared there. We have a screenshot of the that shows the account number of the beneficiary whose IBAN string was registered just you can see this is a screenshot taken from the Mythos community app. This is a UI front-end that was built in G2P API provided environment. This walkthrough, we're going to simulate a payment from government that's going to come from their account. The idea is for the funds to be credited in the beneficiary's account in a DFSP that is Mythos. So what will happen is that when when a payment is triggered from this pair TTK, which is a G2P pair, the payment is going to move through the deployment of modulo. And once the modulo receives this request, it's going to route them to the DFSP to which this pay exists. Now, prior to this, we registered pay in the modulo Oracle, and Eugene just showed us the process, how that was done using the beneficiary management system. So once the payment reaches the DFSP, the DFSP, that is where the MIFOS is deployed. There are two things that usually happen. Number one, the payment is going to go through the adapter. Now, payments are made against an alias, and that's something that should note very importantly. Payments are made against an alias that are generated prior to this. Now, what the payment token adapter will do, it will do a registration, or it will do a registration at the point of creating the payment token. But at the point of payment, it will do a switch out. It will sort of do like a substitution of that alias with the actual string that we registered, which we just saw prior to this point. So once the alias has been switched out with the actual string, that payment request is then forwarded to the core connector, which is the MIFOS core connector in this case, which is deployed. MIFOS core connector, and then eventually translates those modulo specific calls to actual interaction with the APIs. So once the get parties is done and the party has been accepted, and what that is returned from the payee is also accepted by the G2P pair, the payment is executed. The payment is executed through the MIFOS core connector, which is the one that performs the actual crediting of funds of the account of the user, if the beneficiary which the payment is intended. So I'm done with this walkthrough, which is just a visual process flow of what I'm going to show you in the actual demo. So let's get right into it. Yeah, so we're right into the demo. Here on the screen, I'm showing you the balance for the whose payment token was registered prior to this in the beneficiary management system. So we can see that the balance is 9,090 Kenyan shillings. What we want to see is funds being transferred to the G2P pair government credited at this account. So what eventually want to see is that the balance of this account should increase by the amount of money that we're going to send. So here I have the TTK, which is acting as the the interface where we initiate payments with government. I have got the payment token. This was registered the beneficiary management system to the beneficiary registration portal. This is the one that is attached to the beneficiary who was registered, and so going to be a payment to this this payment token. Okay. I also need to show you some of the amount of money that we're going to send. So we're going to send 1,000 Kenyan shillings. 1,000 Kenyan shillings is the amount of money that we're going to send from the G2P payer, and we're going to be making the payment against an alias. Okay, so the alias is the that I've just shown you. Figure here, right? Now let's initiate the payment and see how it goes. Okay, so this first request is an account lookup. So what happens is that this G2P payer is going to request modulo to tell it that which user is connected to this, and in the response we can see that it returns as a user. This is the user that is returned from the modulo, and this was actually the user that was registered in the beneficiary management system against this payment. Okay. Then thing looks okay. We accept the party. We accept the party that has been returned, and eventually we accept the quote to tell Mojalu that we accept the quote. Please proceed with the transfer. Now, the Mojalu instance that we're using is an actual deployment. All these calls are going to that Mojalu instance that we have deployed. When we go back to this screen that shows the account balance, we should see the amount of money that has been posted increase significantly. So the amount is now 10,590, which is 1,000 greater than the previous amount. This successfully proves our step that we're trying to achieve, and we see that the G2P pair module being able to credit funds to hold that in Apache powered TFSP. Thank you.
Thank you, Elijah. That was a really good demo, and I hope that everybody understands what this. This is very. We want to see this being rolled out into ideally live services in the very near future, and we look forward to further collaboration with other DPG projects in the coming months. So thank you very much. So next steps, I want to quickly go through this short presentation. I won't be long, and Paul, please feel free to jump in if you wish. So now we can route to a MOSIP-based digital identity. Where does this lead us? Just some basic identity terminology for people who are not familiar with it. In the identity world, a human is what's known as a natural entity. So we have an identity number, which is therefore a natural entity identifier, or NEI. And a MOSIP token is an example of an NEI, though just to note that is a bit simplistic because of privacy. You get different tokens depending on the particular service provider that you represent. By contrast, an organization, be it company, government, whatever, is a legal entity, and an identity number is a legal entity identifier. There are many variations of this, but the one that we are particularly looking at is the LEI, which is defined by the Global LEI Foundation, which was developed out of the FSB back in 2014. Initially, it was only in the financial sector. It was used for identification of which counterparty you were dealing with in terms of transactions. But now it's increasingly being used for payments as well, payments to corporations or to governments, for example. So the immediate roadmap influences, well, there are clear synergies, as I hope you've seen during today, between the inter-scheme and merchant payments work streams. So routing to a merchant ID in a cross-border transaction, using our initial thoughts were around using a country or a scheme ID as part of the merchant ID, perhaps some form of preposition. And I know that Karim and Michael have both been involved in discussions with that with me, which is how I know. A merchant ID is, as it stands now, as currently implemented in the merchant payments workstream, is an identifier for a legal entity, the merchant. So we're looking at possibly extending that to use LEIs as an identifier. And in support of that, Leaf has an API-based LEI lookup. You pass it to an LEI, it comes back with the country that it was registered in and the name of the organization. And we could use that potentially as part of the routing to a particular motor loop scheme. We could do our own LEI mapping to country and merchant ID, something like that. I hope you're getting the impression there are no decisions here. This is all stuff that's open for discussion. For merchant registration, we look to enhance
the merchant registrations process to capture LEIs during merchant registration, perhaps even to assist merchants registering for LEIs. And to use the Glyph terminology, we're not proposing to become a registrar because that's too rich a function, much too complex a function, but instead as an LEI validation agent, so acting as a go-between between a merchant and a registrar. And maybe there's an opportunity there to look for a portion of the fee. I don't know. We're currently developing process flows for this concept, and we want to do some validation with Glyph, and also we'll look to perhaps validate those as well with the inter-scheme work stream and the merchant payments work stream. Still very early stage here, but this is the way I can see it developing. The LEI can never actually replace a merchant ID, because an LEI is a 20-character alphanumeric. So although you could be using it in QR codes, you're never going to be using it in USSD, which, apart from the fact that you're not going to want to enter a 20-digit number, it's alphanumeric. So you can't use that with USSD, obviously. I think the key here is what we do about tier 4 merchants, which are micro SMEs. A market trader is never going to register for an LEI for reasons of cost, tax, etc. As an experiment, I went and registered an LEI, and I found that it was a very smooth process. It took me a matter of 10 minutes to actually register. It cost me $60 though, hence the issue with market traders, for example. And then I got my LEI within a few hours. So it's interesting, but maybe not right down at this bottom level, the micro SMEs. So we can continue to use merchant IDs alongside LEIs. But what I think is particularly interesting is that most market traders and so on, they're actually individuals, sole traders. So maybe there's an opportunity to build on our MOSIT work to allow them to use NEIs for routing alongside LEIs, which would also strengthen our regulatory AML credentials, because what we're particularly looking at is tier 4 merchants in cross-border transactions, which is a significant use case. Why do we care about tier 4 merchants? This is why. They're 90% of all firms. They represent 70% of the workforce in any country, on average, obviously, and 50% of the GDP. These are all figures that were presented by the UNDP at a conference Julie was at last week before. And I think it emphasizes precisely why. Okay, we can look at LEIs, and that would help us a great deal in terms of our compliance and AML processing. But until we have a solution for tier 4 merchants, which I think should be around natural entity identifiers, then we're not doing the job properly. So challenges: we need to think about the implications for discovery and payments routing, and we need to look at the integration of merchant registration with the LEI registrar's processes. So that's just some thoughts, and I think that is going to become a work stream quite soon. So thank you. Before I actually hand over back to Simeon, I actually want to give Paul Baker the opportunity to make some sort of comment here, because he did almost all the work. Well, he and his team, along with Elijah and Spark Systems. So, Paul, do you want to make a comment?
Only that it's been a fun experience so far, and I think we are making headway. And keep up the good work, Paul.